Hello everyone, myself Janan and we are learning basics of operating system. In this video, we will be talking about process scheduling concepts such as CPU I/O burst cycles, types of schedulers, three types here we are going to discuss. Then we will talk about preemptive and non-preemptive scheduling, that is types of scheduling. Then we will talk about dispatcher and finally we will conclude the session with CPU scheduling criteria. So let's see the concepts one by one. What is CPU and I/O burst cycles? Process execution consists of a cycle of CPU execution and I/O wait. Process executions begins with a CPU burst that is followed by an I/O burst which is followed by another CPU burst and then another I/O burst and so on. Eventually, the final CPU burst ends with a system request to terminate execution. Here in this slide, we can see execution of process with alternate CPU and I/O burst cycles. See here process starts with CPU burst and load, store, add, store. These are nothing but the instructions that are executed by the CPU. Then CPU wants to perform some input output activity, so for that purpose process is going into the I/O wait, that is input output wait. So after wait for input or output, once it is done, that is I/O completion, process or CPU will again execute some part of the process, that is some instructions, that is store, increment, index, then write to file. Then again there will be I/O burst, then CPU burst, I/O burst and so on. So here we can say the process execution alternates between CPU burst and I/O burst. It starts with CPU burst and ends with also CPU burst. Okay. Now let's talk about the types of scheduler. Note that for execution of any process, OS must select any one of the available process from ready queue for execution. This task is done by the scheduler. There are three different types of schedulers: long-term scheduler, short-term scheduler, which is also called as CPU scheduler, and finally the medium-term scheduler. In batch system, more processes are submitted than can be executed immediately. We have many number of processes that are put into the main memory. These processes are spooled to a mass storage devices. The long-term scheduler or job scheduler selects the process from this pool and loads them into memory for execution. The long-term scheduler controls the degree of multiprogramming. So we can say the long-term scheduler selects processes from the process pool and loads them into the memory for execution. Then let's talk about the short-term scheduler or CPU scheduler. It selects from the among processes whatever is available in the ready queue that are ready to execute and allocate the CPU to one of them. That is the task done by the CPU scheduler. So when we talk about process scheduling or CPU scheduling, so this is nothing but the scheduler about which we are talking. And then finally medium-term scheduler, which is used to reduce the degree of multiprogramming. How? By swapping out processes as and when required. Now let's talk about scheduling types. There are two different scheduling types: preemptive scheduling and non-preemptive scheduling. Let's understand what is meant by preemptive scheduling. A process may be forced to relinquish the CPU and some other processes scheduled for execution. That type of scheduling is called as preemptive scheduling. In preemptive scheduling, resources can be taken forcefully from the currently executing process. So as we are taking the resources from that process goes into the waiting state, and that preempted resources can be given to the other process for execution. This kind of scheduling is called as preemptive scheduling. Another type of scheduling is called as non-preemptive scheduling, where once the CPU has been allocated to a process, the process keeps the CPU until it releases the CPU either by terminating or by switching to the waiting state. Here in case of non-preemption, once the resources are given to the process will keep the resources till the completion of that process or till that process is going into the waiting state and leaving the resources voluntarily by itself. So that is nothing but an example of non-preemptive scheduling. Now let's talk about the dispatcher. This is one of the important module, or we can say the program, What it does, the module that gives control of the CPU to the process selected by the short-term scheduler, that module is called as dispatcher. See, very interesting. The task of CPU scheduler or short-term scheduler is to select next process for execution. However, the dispatcher does the task of allocating CPU to the process selected by the short-term scheduler. So here what task or functions that involves in the scheduler or dispatcher, that is number one, switching context, then switching to user mode, and then jumping to the proper location in the user program to restart that program. So here switching context means what? Stopping one process and starting other process to run. That is nothing but the context switch. Here in case if the process has already scheduled before some time, so it might have executed few instructions. So assuming that this is the process or program, and from that program these many instructions have already executed, and now these remaining instructions needs to be executed. So this is nothing but the address of the next instruction. Okay, so program counter. So here dispatcher also includes what? Jumping to the proper location in the user program to restart that program. Why? Because previously this particular program is executed up to, for example, line number 3. Now it should start execution from line number 4. So its context is saved in the program counter, and by reading the content of the program counter, that is address of next instruction, the program starts from that instruction. So that's nothing but the dispatcher. Now a dispatch latency, one of the important concepts that we must know. What is the dispatch latency? The time it takes for the dispatcher to stop one process and to start another running, that is called as dispatch latency. See, what dispatcher has to do? Dispatcher has to stop the currently executing process, so it cannot immediately start another running. There is some time delay. That time delay is called as dispatch latency. That is the time taken by the dispatcher to stop one process and start another running. That is dispatch latency. And now finally we will talk about CPU scheduling criteria. These criteria are very important because we use these criteria for comparison of the scheduling algorithms. See, we need something. Based on that we are going to compare the scheduling algorithms, and these algorithms we are going to select or use in our particular operating system. So these criteria are suggested for comparing CPU scheduling algorithm and to decide which is the optimal scheduling algorithms. First criteria is CPU utilization. Normally we want to keep the CPU as busy as possible. Why? Because CPU is an expensive hardware and we cannot keep the CPU idle, that is doing nothing. So our objective is to maximize CPU utilization. For that purpose we want to keep the CPU as busy as possible. So select an algorithm which will keep CPU utilization maximum, or which will keep CPU busy as possible. Then another measure of another criteria is throughput. What is the throughput? The total number of processes completed per unit time. Here assuming that in 1 hour by using one particular algorithm 10 processes are completed, and by using second algorithm, another algorithm, 20 processes are completed. That means we are going to use the second algorithm. So that is nothing but the throughput. So we want to maximize the throughput. We want to maximize the number of processes completed per unit time. So select an algorithm which will give us maximum throughput. Next algorithm scheduling criteria is turnaround time. What is turnaround time? The interval from the time of submission of a process to the time of completion of the process. That is called as turnaround time. Now what is meant by submission time? The process is arrived in ready queue. Now the new process is created and now it is submitted to ready queue. Now process is ready to execute, but it haven't got the CPU to start the execution. That means it is waiting for CPU. So that wait time plus the burst time or execution time of the process, that combinedly makes the turnaround time. So we can say turnaround time is equal to burst time plus waiting time of the process. Okay, then let's talk about waiting time. What is waiting time? Another criteria, CPU scheduling criteria, which says waiting time is the sum of the periods spent waiting in the ready queue. What it is? Process is newly created, submitted to ready queue, CPU is not available, so process is waiting in the ready queue. However, once the process got the CPU, process will go into the running state, and while running the process may wants to perform some input output activity. For that purpose process again going into the waiting state. So that time period, that means it is waiting for some input output, it is also waiting in ready queue. So that all times period that a process spends waiting for the CPU, that is called as the waiting time. And the last CPU scheduling criteria is the response time. What is response time? The time a process takes, a time that process takes to start responding, that is called as response time. It is not just when process starts giving the output, it is when the process starts responding, that is nothing but the response time. So we want to minimize the waiting time, we want to minimize the turnaround time, we want to minimize the response time. So these are nothing but different CPU scheduling criteria which we will be using for comparing CPU scheduling algorithms and to evaluate the scheduling algorithm. To evaluate the scheduling algorithm means what? To find out which of the algorithms is the optimal one. Is this clear? Now in next video we will be talking about actual CPU scheduling algorithms. Thank you.